Welcome ROS developers to the second episode of this ROS project series on building a robot that takes orders in a restaurant to the corresponding tables. So in this second episode, what we are going to work on is in the tough part. So I highly recommend you in any robotics project that you always start from the elements that are not built, the most difficult elements, because in this case, in this project, navigation which seems really difficult actually is really easy, just because it's already done in ROS. So you have a whole stack and loads of examples showing you that it's possible to do it. But what you can't find is a program in Arduino that publishes ROS messages of the readings of the load sensor, and also a program that converts that in a way that tells you if the customer has picked up the order or not, or if someone has put an extra object on top and this kind of stuff. So there's nothing there. There's not even a simulated plugin. So everything will have to be done from scratch. That's one thing. And the other one is the web app, which there are examples on how to do certain stuff, but there's no example of our situation. So we want a web app that has the tables and the calibration and a joystick and so on. So we need to know that this is possible to do it. So we will start with it. So the first step is to install the Arduino IDE, which is quite simple. You just go to the download page, and there we download the version for Linux, in my case 64 bits. Okay, once we have the download, we install it wherever we want. In our case, we are going to work in this Barista workspace. Okay, so now we have our Arduino IDE ready to go. So the next step is we go to the folder and we hit sudo install. Done. So we should have something here. There we go. So now we have our simple Arduino IDE. So one of the first things you should do is check that your Arduino is able to this. So the first thing you have to do is check that the IDE can load programs to the Arduino. So I'm going to connect my Arduino, and we're going to check serial ports, and we're going to hit upload. So this is one of the errors that are really common in Arduino. So what we have to do is change the permissions of this port. So mainly to solve this problem, we have two solutions. The first solution would be to just manually execute this command, which you will have to execute it each time you plug and unplug the device. The other option, which is the one that we will use in the future also, is to copy a series of UDEV, basically USB device rules that set the configuration, the permissions, and the groups and the name. So in this case, you have to go to our Git, where you have all this information and other things that we are going to use during this video series, which if you go to Barista scripts, create UDEV rules, is a script that sets this in any device, okay? When you have ROS installed. So for the moment, we won't do that. So essentially what you have to do is execute this command, which adds the user to this dial-out group, then we're going to copy these files. We're going to copy these files, 48 Arduino rules. So if you go to, in my case, I have it here, ROS Barista source, Barista systems, CD Barista systems. There we go. So we have these rules. So if we have a look at them, the ones of the Arduino, for example, essentially what it does is, hey, if you detect this vendor and this product, give it this name, okay? This will set up the Arduino in a way that it will always have the permissions to be able to write on it. So when you go here, so essentially, so we copy these files to this location. So if we have a look at this location, I've already done it. So, and then these, so we have those. And then what we have to do is reload and restart the UDEV. It's good to unplug the USB when you're doing this, and then plug it again. And once it's done, it's done. So now we can upload without any problems. So now we have to install ROS related libraries for Arduino. So the first step is to install this. So in our case, depends on the version of ROS that you have. In our case, it would be melodic. So in my case, I have it already installed, both. So the next step is we have to go to here and install the libraries. So in this case, there's nothing there, so we don't have to remove it. And we execute this command, which will make all the libraries and set up everything so that we have them here. There we go. So in theory, we should have it here. So now if we open our IDE and we go to include library, we have ROSLib. Not only that, but also if we go to examples and we go to ROSLib, we have loads of examples available. Yeah. So for example, we could have a hello world, the classic hello world. And because we have already set up our Arduino, we just have to upload that file and we have hello world. So to make it work and test that everything works, we can launch a ROS core here. Let's go to our base, so ROS Barista workspace, ROS core. We can connect here. Okay, this means that everything went okay. So now if we do ROS topic list, we should see chatter, which is ROS topic echo, chatter, and there you go. So we have our Arduino working. So as you can see, I'm connected through USB to my computer and it's publishing hello world. Yeah, so this is your first test that the Arduino is working with ROS. Great work. Okay, so now what we're going to do is load a program, an Arduino program that reads from the sensor, of the load sensor, and publishes into ROS. For that, we have used a library which is located in this Barista Arduino load sensor HX711. I leave in the video description the original source. But essentially what we have to do is copy again to our Arduino libraries. So we copy this and we have a look at where we have it. So I have it already here. So we do copy H blah blah to here, and we check that we have the libraries there. There we go. So if we now close the Arduino and load it again, we should be able to see in the include library, we should be able to see this library. Perfect. So now I'm going to open the file that I've generated for that, which is in Barista Arduino Load Sensor ROS Publisher. After many tests and so on, I found that the best way is to just do a publisher that publishes the load sensor information, and that's it, nothing fancy. Yeah? And so we just use the ROS library and this HX711, which is basically the chip that converts the load sensor data into something that Arduino can understand. Yeah? It's very, very simple. So it gets the data and publishes. So update units is scale, set scale to calibration factor. This is if you get some readings that are not exactly what they should, so that when it's idle, it should have a value of 0, yeah, in grams. Okay, so around 0. And then we just publish it. So we update the units, which is this units, which is this global variable here. And then we get this units and put it inside a float32 message, and we publish it into a topic called load sensor. That's it, nothing special there. But the complicated part is getting the library and getting the ROS library to work. Yeah, so we upload this to our Arduino. Okay, done. So also, using topics is much more efficient just because Arduino doesn't have a lot of memory. So if you start using services and subscribers and publishers, you'll run out of memory really, really fast in the Arduino. Yeah, just in the code that you have to upload. Okay? Okay, great. So now that we have it. Okay, so once we have our program uploaded, it's time to test if it's working. So again, we go here and we look for the launching the ROS score. Now we launch the ROS serial and we connect to the TTI. There you go, requesting topics. But we have our load sensor. So ROS topic. Echo load sensor. There we go. So now if we press the load, we should get values moving. Perfect. So as you can see, connected the load sensor, and now we have running the ROS score, we have running the ROS run serial, and then we have here publishing data. So as you can see, when I press, it gives me readings. There you go. So if I play something, yeah, around 300 grams, which is more or less the weight that this weighs. So great, we have our load sensor working and defined. So now that we have this working, now we want to create some Python classes that connect and transform these readings, which are only numbers and grams, into something meaningful that the robot will understand. So for that, let's go to our package. I won't go into details on how this works and all that stuff, but essentially this is the one that does the magic. So load sensor is the one that converts this load sensor data from the subscriber to various things. It publishes 2 topics, which is the load sensor information, which is an understandable way of an interpretation of that information based on if it's being calibrated or not. And then we have a server that allows us to calibrate. And yeah, and then we have extra information to know when it's calibrated, what's the reading of that weight. So this load sensor tard essentially gives you a reading of negative if you extract weight from the calibrated. I don't know if it was clear. Okay, so what you have to do is you just have to download this code inside your Catkin workspace, and then you have to install, at least you'll have to install ROS Melodic, ROS W. You also need DroidSpeak. So you'll need this DroidSpeak package made by Gerald Lelong, which generates the sound that we'll use for giving feedback, which we won't talk about today, but we need it to compile. Okay, Catkin make. There you go. Okay, so now we have everything set up here. So let's have a look on some tests that we can have a look at. So we have a launch here, which is load sensor start sub, which, if you have a look here, it depends on if the robot is real or not. So why? Because when it's not real, so simulated, that we'll talk about in the next episode, we need to start a simulated load sensor. But if it's the real robot, then we have to set up the device where we are connecting and all that stuff. Yeah, so bear that in mind. And essentially what it does is, in our case, what we're going to start is this one, and then the load value test node. So this load sensor, which is the one that we were talking about. So if we have a look at what we were talking about, load sensor, and starts this one, which publishes everything. So basically, one launch is for connecting, so the ROS serial, and the other one is to read that data and interpret it. So let's have a look. ROS launch, Barista systems. Okay, requesting topics. As we saw here, it takes a while to make this connection, so don't worry about that. So now, in theory, we should have ROS topic list. Okay, so we have several new topics. So we have our ROS topic load sensor, the classical one, which we press and we have some readings. Then if we do ROS topic echo load sensor info, we see that now we have converted this data into something that it's meaningful. So it says loading tray empty, if I put something, it says, hey, there's something, you have to calibrate it. Yeah. If I get it out, then there's nothing. So this comes to the next one, which is, okay, so ROS service list and ROS service call. We have this load sensor calibrate server, which is the one we talked about. So we want to calibrate. So let's have a look a bit more in depth this calibration, because it's the heart of this sensor ROS node. In the calibration, if we go here, you see that the calibration sensor, when we call it, so let's go here. So calibrate callback, we go to calibrate callback, and here we say, hey, calibrate. So we have two modes. If you send false, like we have it here by default, or true. So let's have a look at calibrate. So is this function here. So this function is if adding object is true, which is basically what we are giving here, data, then it will add an object, and it will consider that an object has been added on top, and it will give information based on that. If not, then the only thing that it does is reset the tar value to 0. How do we use this? Well, essentially, if we put false, it will reset the tard value. So now it's a good moment to ROS topic echo load tard. So as you can see, it's the same values. Why? Because we haven't calibrated it. So the tard and the readings are exactly the same. Yeah. But if I place an object, let's say this, let's say an object that weighs 39 grams, and I tar it, so I calibrate it, so true. There you go. So now they are different. So the readings are exactly the same. This is published by the Arduino, but this is tarred. So now it considers the now it's 0, and now it says object loaded. Perfect. So if I take out the object, it says, hey, the object has been removed. If I put it, then you have it again. So this means that if I go to some place and the robot goes and they pick up the object, it detects that the object was removed, and now he can go back. But he has to recalibrate itself. So now it should do something like this. False. There you go. And now it considers that the tray is empty. So here we have our load sensor. We have running the load class. So now if you can see this, so if I leave an object, let's say this, for example, we put it on top, and now we have the readings. So if I remove this, let's put it a bit here. So if I remove it, again 0, and it says empty. I put it again, and it says you have to calibrate. So now we go here and we calibrate. Yeah. So now it says loaded object. So now if I remove the object, it says object has been removed. So now I go here and I say, hey, I want to reset. So now it's resetting and the tray is empty.